Welcome everyone. Hope everyone is having good weekend. Today's session will cover network security, which is fourth domain in the syllabus. Probably 24% of the weightage you may get from this domain. Network security is one of the key domain in day-to-day life. Without network security, you may not see any computer or any peripheral devices which is connected to internet. Without further ado, let's get started. Computer is powerful, right? So when you do any task within computer is powerful than any individual human or any other, any other kind of calculation. If you do through computer is much faster. It could be editing, it could be processing, or it could be automating stuff within the computer is powerful. But what is more powerful is when computers interconnected. For example, when you connect multiple applications together and work together across different geographic, then you may need network. The network can be formed within your house or without any geo restriction. For example, you can trigger a print from India to US, or you can communicate to anyone through internet, sending email or receiving email, or the collaboration tools such as WhatsApp or the Microsoft Teams call. Now it is happening through internet, right? So whatever task we are doing in day-to-day life, there is a computer network is involved. So multiple computer connect together and we are achieving the specific task or outcome through computer network. So these network might have threads. For example, the network what we connected now is, for example, this is a Microsoft Teams bridge call, which we connected through multiple devices, each individual connected from your mobile devices or laptop, right? We all connected together and having a session on computer network today. But when it comes to threats, what are the threats available? What are the mitigation controls available when it comes to network? Also, how enterprise and individual house network differ, because enterprise would be different and the purpose also slightly different, right? But in house, we may not pay much attention to computer network in our in-house network. So that would be slightly different. I will cover in detail. So let's start with the network types. Most of you aware, we have probably two broader type, local area network and wide area network. Local area network, whatever connected to individual entity or a house is called a local area network. For example, within my house, I have smart refrigerator or smart, let's say, kitchen assistant system. Maybe the smart doors. These are interconnected. I can connect any devices from one another. For example, my mobile can control my air condition temperature, right? So that way the local area is formed, which is under one entity, which is my house. I cannot control others' house or others' smart house system or any other equipment. So all are connected within that particular entity is called local area network. Same goes to enterprise. When you go to company, or for example, if you take your university or college, the entire college systems may interconnected to connect and share files each other. That is within that particular college or university, not outside university. That is called the local area network. Local area network exam standpoint, you should know 802.3 and 802.11. 802.3 is the standard, IEEE standard for wired Ethernet. You might have seen RJ45 cable, or the cable you are connecting to get the internet from the router, which is called wired Ethernet. The standard is 802.3. This is pretty old and you may not see nowadays, but still if you connected to your college, university, they prefer cable connection than the Wi-Fi or other mode of the communication. They still connect desktop computer with the internet connectivity that keep blinking with the orange light, right? Orange or yellow light. That is called Ethernet cable. 802.3 is the standard. When it comes to modern world now most of the houses have Wi-Fi router or modem from BSNL or Geo, whatever ISP you purchased internet connection. They give you modem that gives you Wi-Fi signal, wireless, basically wireless. Using that radio frequency, your device get connected. That is called IEEE 802.11 wireless Ethernet standard. So you need to remember this 802.3 and 802.11 in exam standpoint. So 802.11 is always referring wireless Ethernet. Now I come to service set identifier. What is that? SSID. When you turn on Wi-Fi in mobile phone, you will see list of available networks around in your house. That is called service set identifier. That is being used in wireless network, which is called Wi-Fi. In Wi-Fi, it will broadcast to anyone. When they turn on Wi-Fi, they could see the service set identifier, which is called SSID. For example, when you share your internet with your friend or colleague through hotspot, or one device to another device through hotspot, that hotspot identifier is called service set identifier, SSID. So you turn on hotspot, you kept some name in your mobile phone, then you go to PC and identify that name, right? The term here is called service set identifier. Wherever you see SSID, you just imagine there is a way to connect to the Wi-Fi. That SSID is used. That is used to connect to the particular network through wireless medium, which is 802.11. Now come to wide area network. Local area network, how it is within entity. Wide area network doesn't have any geo restriction. You can connect from India to US or your house to anywhere else. You can send email, you can connect to anyone over video call or audio call through internet. That is called wide area network. Wide area network primarily pass through multiple internet service providers, get connected to various devices and pass the connection to respective service. Take an example. You are watching some video which is hosted in America, YouTube company. The video, they kept it in CDN or a content server where it is located in America. Now you are from India, you are watching that content. That content streamed you through internet that passed through multiple oversea or undersea fiber cable to reach America data center, and that data transfer happens immediately. So you won't even see the latency or lag. That's how wide area network is powerful and you can connect. Primarily wide area network uses public IP, local area network uses private IP ranges to interconnect. So wide area network may use IPv4 or IPv6. Next set is personal area network. What is PAN? PAN nowadays much popular because now you connect your wireless headset, which is Bluetooth headset, from your mobile phone. The car has remote key to start the car without before entering, or you have anything related to Bluetooth. The device is connecting to Bluetooth, for example, your mouse or keyboard, the wireless mouse. These all are using personal area network. The range is 10 meters. We do have NFC. You might have seen NFC card in maybe abroad. They do NFC payment. They just tap the mobile phone and pay through NFC. iPhone to iPhone, they can transfer files using NFC. So these all are called personal area network. Primarily Bluetooth, NFC, within 10 meter, no internet needed. You just need two devices with compatible with personal area network such as Bluetooth or NFC. They can transfer file or data between one system to another system or one mobile to another mobile. That is called personal area network. Quick summary: network types, LAN, WAN and PAN. These three you must aware of. So next we'll go into TCP IP networking. So TCP IP, we have two protocol here, transmission control protocol and IP protocol. This protocol runs the internet. If you take anything, you take Facebook, YouTube, or the current MS Teams conference call we are having, these all running over TCP and IP protocol. Transmission control protocol, and the second part is the internet protocol. Internet protocol used in LAN and WAN. What does that mean, LAN and WAN? You have an internet connection purchased from BSNL or Jio from the internet service provider. They installed you a set of the Wi-Fi modem in your house. That modem acts as a DHCP server and it forms a local area network. So your mobile phone, your father's mobile phone or your mom's mobile phone all get connected to that same Wi-Fi so that they can connect it to internet, right? So how the each individual device know, the Wi-Fi modem aware where I need to send the traffic to. For example, my father is watching video, I am using Facebook, both are connected to Wi-Fi modem. Now this Wi-Fi modem know when my father was watching video, his traffic go to his mobile phone, my traffic go to my mobile phone. It shouldn't be interchanged or the mistake never ever happened. So that uses TCP IP protocol. The IP address get assigned to each individual device is unique. Unique IP address get assigned in your private network. Probably it may use private IP address, but still IP is the primary unique identifier to identify the device in the network. When it comes to large files, right? For example, I'm downloading maybe 1 GB video file from YouTube to my mobile phone. This 1 GB file will not be get downloaded as a single file in network world. Network world, this 1 GB get fragmented into packets. Each packet probably few kilobytes of data and multiple kilobytes of bits and pieces of packets being transferred over the wire. Then it get arranged back into 1 GB file so that I can watch that full file as a single file as a video file. Now this process taken care by internet protocol. So internet protocol breaks it up into small pieces called packets. So in wire or wireless, our data go as a packets. When you connect to WhatsApp, your data goes as a packet. When you watch video, your video stream goes as a packets in the wire. Whenever you connect internet through browser, any website you are browsing, your entire traffic breaks into small piece of data called packets, the size in kilobytes. So this process taken care by internet protocol. The internet protocol will add the header and the routing information to reach that specific destination using internet protocol. Now come to TCP protocol. As I said, we can't send that entire file as a single file, like 1 GB file download in a single file, because if 1 GB file failed to download, I need to reinitiate the entire 1 GB again and again. That overwhelm the network, as well as that is not a reliable solution, right? Let's say if I convert that 1 GB into multiple packets, maybe 1000 packets. Among 1000 packets, one packet lost in the network. What will happen? That lost packet again recalled and resent from the source to the destination. So that way, no longer needed to send entire packet back. So the TCP protocol is responsible for setting up and tearing down the connection between source and destination system. For example, I start sending a file from WhatsApp to my friend. The moment I send a file, that may form a connection to the server and server to the respective person. Now, once the file is completed, the transaction, the TCP connection get killed or terminated. That process taken care by TCP protocol. Also, TCP tracks the packet that are sent and controls the rate which packets are sent. For example, you have high bandwidth internet connection. Let's say your internet speed is 100 Mbps. Maybe you are in rural area, 100 Mbps. But your friend got 1 Gbps. He is in maybe a metropolitan or a town or a city where he got better internet connection. You have only 100 Mbps speed, but your friend got 1 Gbps speed. The moment you send the file, let's say you are sending 1 GB file, for you 100 Mbps is the maximum speed you can achieve, but your friend 1 Gbps, right? So this difference shouldn't create problem because TCP protocol tracks the packets and it knows the bandwidth availability of that channel, also the buffering or any packet loss. Based on that path bandwidth, it will adjust and send the packets accordingly. If a packet is lost, let's say the chunks of the packets get lost or damaged along the way, the TCP will request that sender to send the packet again. Also responsible for correctly recording the packets at their destination. So once 1000 packets reach the destination, TCP will reorder the packets and create that original file, whatever file the user sent originally. In man in the middle, if someone take a capture or someone steal the information, they only get the packets. They can't organize that as a file, but they can see the packet information. Man in the middle if it is plain text. Next we have user datagram protocol, UDP. The TCP has reliability acknowledgement process. UDP doesn't have acknowledgement process. Because of that, UDP packet header size is less as well as much faster. Whenever you develop any application which requires fast connection, then you can go with UDP. Also, UDP you cannot expect reliability or the error control because UDP never care about whether the packet delivered or not. It will go to next packet like that. For example, you are sending 1000 packets. In the middle, 3 packets get lost. Then UDP will not care about anything. That 3 packet let's get lost and continue rest of the process. 997 packets reach the destination. But when it comes to TCP, those 3 packets informed to the sender. Sender will resend those 3 packets back to the receiver. UDP is suitable for fast applications such as video streaming, YouTube or Netflix kind of application, not suitable for net banking or wherever you need critical packet control. When you watch YouTube, let's say 3 packets missed in the stream, you see some 3 dots black in the video, you won't realize, right? That won't be a problem. But when you make a transaction in net banking, if 10 packets lost, your transaction may end up with the failing. So while designing application, while choosing the protocol, they select TCP for critical applications and business applications, UDP for application which requires fast transfer. Next protocol is Internet Control Message Protocol. Let's say you have two systems. It could be LAN or it could be WAN. For LAN, the two systems available in the single network or within your house. Let's say you have one mobile phone, one computer, or in wide area network. You are sitting in India, your colleague or friend sitting in other country. Now you both know your IP address. You are trying to ping each other through command line. Now that availability test taken care by Internet Control Message Protocol. Primarily this protocol is called housekeeping protocol to test and diagnose whether the opponent system is available and ready to accept the traffic. For example, before I start sending the file, my system will do auto check whether the host is available or not. If not available, it may throw some error before initiating the file transfer. That is where ICMP used. But in person, I personally use ICMP to troubleshoot internet connection. For example, you are setting up an internet for your house or company. When you say one computer is not working or not connecting to internet, you can start troubleshooting, sending ICMP packet to your Wi-Fi modem or internet to see where the packet is failing. ICMP can be used in multiple ways. There is a traceroute command or ping command that can be used to troubleshoot readiness of the internet or connectivity. So ICMP protocol is fall under a TCP IP suite, and a housekeeping protocol. It is primarily not used for file transfer, but before file transfer or before any communication happen between two systems, ICMP protocol may be used to check the path and availability of that other system, other end system. So now come to OSI model. This one slide is very important. OSI TCP IP model. I just mapped both the model in one table. You must know the first 3 layer in the OSI model is equivalent to TCP IP model. So OSI model is an open system interconnection model. You consider OSI is the latest model. TCP IP model is the traditional or very old model which was exist the moment we invented internet. Okay, put that way. So TCP IP model is very old, OSI model is latest. We no need to go into that which year it was invented, who invented. We no need that data for exam perspective. But you need to know in application layer for TCP IP model, we have only 4 layers in TCP IP model. Application layer, host to host layer, internet layer, network access layer. Only 4 layers in TCP IP model. That 4 layers mapped to OSI model. OSI model has 7 layers. To remember 7 layers, you can use this mnemonic word which I given in the bottom. All people seem to need data processing. So all, A for application layer, people, P for presentation layer, same session layer, 2 transport layer, need, N for network layer, data link layer, processing physical layer. So if you have problem or struggle to remember these layers in order, you can use this mnemonic. I don't want to limit this mnemonic. There are a lot of mnemonic available on internet. If you search, you will find multiple mnemonic. Whatever mnemonic you just comfortable using, go ahead. I used to keep in my mind PDN TSPA. I go from bottom. PDN TSPA, physical data link network transport session presentation application. Why I said this slide is important? whenever you take any network exam in future, not only CC exam, CCNA or ethical hacking, so multiple exams covers OSI model. So once you invest your time to remember all the layers and all the process available in this layer, you must store that information in your muscle memory so that whenever needed you can reuse it. So now application layer in TCP IP model mapped here as the upper layer. Upper layer is here 5, 6, 7 in OSI model. Session layer, presentation layer, application layer. These three layers are called upper layer. Upper layer mostly fall under application. Okay. Below the transport layer, network layer, data link and physical layer called lower layers in OSI model. Now come to OSI model. Within application layer, we need to talk about a specific application. Where we are starting our application. The application could be WhatsApp, browser, Outlook, email. Some of the application you are using on the system, right? If you take mobile phone, it could be WhatsApp, it could be Facebook, it could be Gmail, or any app you are using on your mobile phone. That is fall in application layer. But in technical, that application may use HTTPS protocol. You go to WhatsApp, WhatsApp is using HTTPS protocol. You go to Facebook, Facebook is using HTTPS protocol. So that is where application layer starts within the application in real time. Then presentation layer used for data translation and encryption. If you use WhatsApp, WhatsApp is using end-to-end encryption. No one can see what you are sending inside the channel, or if someone is eavesdropping or tampering in the middle, they can't see what you send to your friend through WhatsApp. So WhatsApp is using encryption. Similarly, Facebook also using encryption, your Gmail also using encryption. This encryption fall under presentation layer. Now, session layer, when you on a live session, for example, you are authenticated to Gmail and you are keep accessing. Whenever you open new tab, Gmail will not ask you credential again, because your session is already established between your device and Gmail server. That is session layer, exchange between systems. Transport layer, from your device to Gmail or WhatsApp or Facebook, the data go in a chunks as a packets, get transferred in a packet. That is taken care by transport layer. Network layer, which uses IP protocol, internet protocol, to route where to go, where the device is located. For example, in-house, let's say you are connecting mobile phone with your air conditioner. There is no confusion. You go to your mobile phone, you are controlling your air conditioner through mobile app, which is connected over Bluetooth or through Wi-Fi. Now, both the devices in your house, which your home modem is connecting both the devices. So the network layer is very short, and your mobile send the packets, your modem transfer the packets to air conditioner. Both the devices get connected. But when it comes to Facebook or WhatsApp or something in other country or other side, in the geo, it go to your internet service provider, could be Airtel or BSNL or whatever mobile carrier you are using. That forward the traffic to internet and that reaches the destination. That is where internet protocol come into picture, that fall under network layer. Now, data transfer between two nodes using data link layer. Data link layer responsible for transferring data between two nodes. After the packet is get converted, now the data to be transmitted, right? So that data link layer would help. Physical layer is a medium. The medium could be wireless, 802.11, right? The wireless. It could be Wi-Fi, it could be mobile signal, it could be Ethernet cable. These all fall under physical layer, right? Mostly nowadays we are using optical fiber. These fall under physical layer. I would like to explain one thing, that the process never happens in a sequential order. For example, you are sending something from your mobile device. It will not go to first application layer, next presentation layer, next session layer. It will not go like that. These all work parallel. The moment you open Facebook application, your application get connected already to the Facebook server. That's why you are seeing login page. Your data already encrypted. Your session already established upon your successful authentication. Your Wi-Fi router already connected using wireless Wi-Fi. So whenever you use computer or mobile phone, remember this OSI model. This is already running parallel. Even if I take this MS Teams meeting, my Teams meeting application is Microsoft Teams I am using, which is HTTPS, or it may use UDP for fast delivery, because I am speaking, you are listening with different geolocation. So to deliver fast performance, Microsoft is using UDP as a protocol to deliver my video and audio or screen sharing to your device. So that uses UDP in transport layer. In presentation layer, I already logged into Microsoft Teams account. The session already established with Microsoft server. Transport is UDP or TCP. Protocol, already IP protocol is used to connect to the Microsoft servers. Data link, from my laptop, the data is being transmitted to your devices using data link layers. I'm using Wi-Fi to connect my laptop to internet. Physical layer, I am using Wi-Fi. You are using SIM card with your mobile phone, mobile network, or if you are using Wi-Fi, your physical layer also Wi-Fi. So sender side and receiver side, these all 7 layers work parallelly together to connect one device to another device. So now application layer, you must know some few applications. For example, SMTP, SSH. These are other applications available, but most common is HTTP and HTTPS. So application layer primarily designed for that specific purpose. For example, browser designed for connecting to any website. If you take a command line with SSH protocol, that is developed to connect secure shell with the application. If you take SMTP is a email server to send and receive email, that is purposefully developed for SMTP. So I mean email. So like that, you have multiple applications with specific purpose. So that fall under application layer. So let me take the question from the chat. How is application layer and transport layer different? So the transport layer here is TCP or UDP, but application layer here is, for example, take any website. I go to google.com from my browser. Google.com is a web service. That web server enabled with HTTPS protocol, which is application layer. The application is we don't care google.com or facebook.com. It is a web-based application defined with HTTPS as a protocol to deliver the application to the end user in application layer. Now come to transport layer. As application defined to use HTTPS is TCP protocol. Because when you send anything to google.com, let's say you go and put something on Google search engine, the data from your device sent to Google server for crawling or searching, right? That information passed in your wire or Wi-Fi through TCP protocol. That is a transport that carries your data in packets. Let's say you are typing 2 paragraphs in your Google search. That paragraph converted into packets in the medium, wire or wireless, using TCP IP protocol, that being transmitted in packets in the pipe and delivered to the Google. If someone take that packet in the middle, they only see the packets. From your device to Google server, there is a packet is going. So in more precise, application layer designed by that specific application. Transport layer, they have very few choice. Either they can choose UDP or TCP, or starting with TCP, then they converted into UDP. If you take YouTube, you go to youtube.com, it is asking you to authenticate. The first youtube.com and authentication process uses TCP. The moment you start watching video, the video content delivered through UDP protocol. So they use combination of two protocol in transport layer to deliver much faster application. But if you take any other application other than browser, let's say you have Outlook client running on your laptop, you go and use email, then that Outlook client, while designing that Outlook client, they embed TCP and they embed the certificate for encryption. Then they use HTTPS protocol. So Outlook client always use HTTPS protocol to connect to the mail server and deliver and receive the email through HTTPS protocol. That is in the application layer. Hope this answers your question. So let's move on. All right, next come to IP addressing. As I said, each device in the network get connected to unique IP address. If you are in your house, the entire house, each and every device has unique IP address. But if you take internet, how should I avoid duplicate? For example, the IP I'm using in India, that same IP shouldn't be used in Europe or America where my colleague or friend is living. So the IP address, we have two types, primarily IPv6 and IPv4. Still IPv4 heavily used. Many places IPv6 already migrated, already in use. In IPv4, we have limited number of IP addresses, but within house, you will see unique IPs. The same IP address can be used in someone else's house in the router. For example, in your house, let's say your modem, Wi-Fi modem issued IP address 192.168.1.1 or 1.2. The same IP can be used in your friend house as well because it is private IP, which is used within that Wi-Fi modem. But when it comes to public IP must be purchased from respective internet service providers. So let's say you have Airtel in India, but in US you have Verizon or some other vendor. The IP ranges used by Airtel never be used by other vendor in other part. So that way the duplicate would be avoided. So if someone is sending data from India with the India Airtel public IP, that public IP never ever duplicated in any other place in other countries. So that IP is owned by Airtel, that cannot be owned by someone else in any part of the world. So that's how IPv4 splitted and sold across multiple ISP providers. They use IPv6 or IPv4 conversion to manage the load and capacity or availability, but that's how the communication happens. But you should know the IP address range in IPv4, we have 4 octets separated by dot. It starts with the number 0 to 255 is the number. So you can't see 270 or 256 in any of the octet. For example, the given IP address 10, 15, 100, 240, right? You cannot see the third octet 100, instead of 100 you can't see 270 because the IP range is between 0 to 255. So you can see within 255 limit. If you see 270 or 280, then it is an invalid IP address. So next, how communication, unique IP is assigned to the system when they transfer data. The source IP and destination IP used to identify who is sending, who is receiving the data. That way, the IP address primarily used to identify respective system in the network. So using just IP address, you can connect both the devices without any Wi-Fi router or modem. You just need the cable. You can connect two laptop, you can connect two mobile phone without having Wi-Fi modem or internet. So that way you just need to know how to configure IP address and the gateway. Then you can connect two laptops to transfer data if anytime needed. So that way the source and destination get identified and data transfer can happen over wire or wireless. Now come to IP assignment. How IP get assigned? As I said, each devices in the house get unique IP address. How that get the IP, how devices get eliminates the duplicates. For example, the IP assigned to my mobile phone never ever get assigned to my father or my mother mobile phone. How that is happening? There is a way. So IP assignment you can assign manually, no problem. If you know networking, you know your Wi-Fi modem, you can go to your laptop, you can configure IP address. That is first step, but that most of them don't do, because to do that you need to be tech savvy, or you should know how to configure command line IP address in the computer configuration. That never ever happened. That is not the regular practice in real world. We use DHCP. The Wi-Fi modem comes with DHCP, which is called a Dynamic Host Configuration Protocol. Act as a DHCP server. Your mobile device act as a DHCP client. What it does, as soon as the Wi-Fi get connected, the DHCP server will check how many IPs I already issued to other people in the network. The next available IP will be given to the person who is connecting through DHCP. Now you go to your home and you have a new mobile phone, brand new mobile phone. You just turning on the Wi-Fi. Now your mobile, the Wi-Fi modem has that intelligence. There is a new device, Wi-Fi is get connected. I need to give the IP using DHCP protocol. Once the IP get assigned, that IP stick to your mobile phone. Whenever you go back to your house and turn on the Wi-Fi, that same IP used for you, that same IP never ever given to any other device. That is called IP stickiness. Now, let's say if some reason the automatic IP assignment is failed, then APIPA come into picture, automatic private IP addressing. It uses 165.254 range IP address. If you ever see any of your devices get connected with 169.254 subnet, then what it indicates, it is called APIPA, automatic private IP get assigned to that device to temporarily connect the modem. Once it is successfully connected, the IP may change to the right IP address within the range used by your Wi-Fi modem using private IP addresses. So IP address start with 127 is a loopback. In real time, you go and stand in front of mirror and talk to yourself. That is called, self, talk to yourself, right? You are going to stand in front of mirror and talking to yourself. You are not interacting with any other device, right? For that, loopback address would be used. The loopback address start with 127. Primarily 127.0.0.1 is the loopback address. They call it as home address or a loopback address in real time. You might have seen some memes around loopback address as well in internet. But this loopback address, if you ever seen, there is no other party connected. The loopback address, let's say you take some capture from the Wi-Fi or a wire, you have seen in the network logs 127. That clearly indicates the system talking to the same system or within the process. Within the system, somehow the device is talking itself. The traffic is not getting connected to someone else or other device. It's a loopback address. So primarily this is not a valid address. This is just a way to the device self-talk. My mobile talk to my mobile only. My computer talking to my computer. But different process. Let's say my command line talking to my web server. Both are running on the same device. My mobile phone, I enable to debug I am a developer, I am debugging something within the mobile phone, then I may use loopback address to understand the website or whatever application running on the same device. So 127 is not a valid IP address. It's a loopback address talking to same device. APIPA is called automatic private IP addressing that start with 169.254. DHCP. So DHCP is primarily automatic assignment of IP address, so that whoever come to your house, you just give the Wi-Fi user ID and password, done, they get connected. We no need to assign IP address manually. That is taken care by your Wi-Fi modem using DHCP protocol, dynamic host configuration protocol. In this slide, whatever I repeated again and again, that may you may expect that concepts in exam, so prepare. Now I take the question: is there any case where loopback is used? Loopback is used more often in developer community, as well as some of the applications interconnect. For an example, to reduce the cost, what developers do, they deploy IDM or whatever developer tool they are developing the application. For example, the developer is a web developer. He installed local Git instance on the laptop. He developed a code as a web page, sample web page. Now the problem is the code sitting on his laptop, the module or whatever Git or whatever library needed, HTML or PHP, resides in his laptop. Now he wants to test that code, how the web page looks like. What he will do, he go to browser and type 127.0.0.1 : he will assign specific port number in the Git. Let's say 9090. Enter. He will see the web page in the browser. That is one primary use case you widely seen all the developer community aware of. Here, how they are reducing the cost. He is not hosting that web page in any GoDaddy or any web server. Instead, he is using his browser as a local browser, his device as a server. So both are resides in the same device, self-talking each other, but the developer is reviewing his code, how my site looks like the web page looks like, or do I need to modify any code, or how the view or UI UX like. So huge developer community rely on loopback. Then loopback IP you might have seen in many of the applications. For example, you go to Outlook, thick client, the Outlook software used for mail delivery, or the MS Teams application, or a Zoom application you install on the device, that uses loopback to communicate to your audio driver or audio interface on specific port number. So what will happen when you go and launch that application? That go and install some web component on your laptop, then that connects that service over loopback IP with the port number. So there are wide variety of use cases in the loopback, but the loopback cannot be used to communicate to other devices or other system. Always the use case relay or resides within that specific system for various purpose. On my top of my mind, I remember developer community and thick client softwares. All right, next, how to find valid IP address. You may expect question to find valid IP address. Already I have discussed loopback IP, which is start with 127, is not a valid IP because that is talking to self systems or self resources within that system. Next, the octet, IPv4 octet range is 0 to 255. If you see beyond 255 any octet, that is not a valid IP address. Next, the first value never be higher than 223. If it is beyond 223, then that is not a valid IP address. So this is for a public IP. You may expect a question, they give you 4 IP address, option A, B, C, D, and ask you to identify which one is right or valid IP. You need to apply this logic. If there is IP with 127, that is not a valid IP, you can eliminate. If there is IP having any octet above 255, that is not a valid IP, you can eliminate. If there is IP's first octet is 223 above, higher than 223, then you can eliminate. So these three things you just need to remember. Probably I put one quiz question somewhere. Maybe that time you can apply this logic. So remember, the range should be 0 to 255. 127 never be a valid IP. The first octet of the IP address never higher than the 223. Domain name system. This is one important concept. Without domain name system, nothing exists in the internet. As we talk about IP address, each device having unique IP address. Let's say I want to connect to my printer. I can't remember my printer IP address every time while sending print. I can't remember my friend email IP address while sending email. I can't remember Google IP address while connecting Google search engine or YouTube, right? So IP address is for system, devices, application, not for human. For human, we need easy name, like to call that name so that I can easily remember. When I go to browser and access google.com, I know google.com is a single word that I can easily remember. If you say Google IP address is 10.1.6.9, I can't remember all the time. So to make that easily human can remember, we have domain name system that basically converts name into IP address. If you put google.com, that get converted into IP address. That's where domain name system come into picture. Domain name system itself very vast topic, very broad domain. There are specific department available in DNS itself. There are a specific job role also available for DNS. If you interested in this topic or do some research to publish papers or start your career in domain name system, there are various resources available. This is just a narrow domain, but when it comes to internet service providers, they have dedicated subject matter experts for DNS. They use multiple protocols and security systems to safeguard the domain name system. So the domain name system problem is if the threat standpoint, if someone go and modify the Google IP address to the hacker IP address, which is called DNS poisoning, then users are routed to the bogus or a dummy server where hacker can host a page like Google and harvest your information. So those risks are heavy in domain name system. So our ISPs put extra effort to secure the domain name system. We'll see some mitigation and techniques here. So network ports and application. As I said, a single system, we are running multiple services. Take your Windows laptop as an example. Basically what you have a browser, you have Outlook or a Gmail client, you may have command line. If you are a developer or a techie guy, you may install Git or other technical related, the coding thing. If you are a hacker, you may install some of the scanning tools or exploit tools or even install VM, right? So multiple applications running on your single system. As I said, one IP get assigned to your system, but how to differentiate these applications? Primarily used by ports. Ports is nothing, just identifying the respective services on the system. Another example, take your mobile phone. You have WhatsApp running always. You have Facebook application running always. Let's take another application, maybe the commonly used. Let's say you have Amazon online shopping application available. But you have single IP address assigned to your mobile phone by your Wi-Fi modem, right? That is the unique identifier you have. When Amazon or WhatsApp responding back with the information that receives your Wi-Fi modem and Wi-Fi modem trying to send that information to your mobile phone correctly identify the packets based on the port number. That is where port number come into picture. In real local example, let's say you are guiding someone to the address. Go to 16th Cross Street, first building, maybe building number 100, first floor. Now, you have guided him to go to that 16th Cross Street. That is your, let's say, consider as IP address. You reached that 16th Cross Street. 16th Cross Street, we have maybe 100 houses, right? In 100 house, you have building number, let's say building number 10. You are giving one identifier, that is called a port. Now within that 100th building, maybe floor 1 or 2, like more information about the process or application. Here it could be Facebook or WhatsApp. So in computer world, when packet received from the internet, that internet could be WhatsApp or Facebook or whatever application, to identify the respective application, port number is used. But you cannot use random port number to identify the application. There are some criteria defined by our internet governing bodies. Port number 021023 called as well-known port number. If you take HTTP, HTTPS, port 80 and port 443 within that 1023 range, right? So that cannot be used by someone else. If you take port number 1433, which is registered port number. So the registered port number from 10242 to 49151 are known as registered port number. Whatever port number above 49151 till 65535, dynamic port number. So I repeat, port number between 0 to 1024 called as well-known port number, that cannot be used by anyone else. That is used by respective protocol or services by governing authority. Not for public, it's well-known port number. For example, port 80 HTTP, port 443 for HTTPS. This is just an example. Now come to registered port number, which is start from 1024 49151, which is called registered port number. This registered port number, let's say you are a application owner, you need some fixed port number to route your application, then you can apply that, register your port, you get confirmation like Microsoft did for SQL, which is 1433. Oracle did for 1521. So that way you can get your own port number. Anyone can register, only Microsoft, Oracle can register, not like that. If you have proper application which is running widely and you have a justification, you can request and register your port number. But when it comes to port number 49151 to 65535 is a dynamic port number, temporarily used for application, anyone can use. So mostly applications using these port number above 49151 are temporarily developed applications, or the applications locally developed, not that popular. So they use random port number to connect. For exam standpoint, you need to know what is well-known port number, which is 0 to 1023. What is registered port number? 10242 49151. What is dynamic port number? 49151 to 65535, or dynamic port number. Port number, the final ends 65535. So beyond that, you can't use any number. Now I just put some few examples. Port 53 used for DNS, 2122 used for FTP, port 80 used for HTTP, port 443 used for HTTPS, which is encrypted, port 1433 used for SQL database, 1521 Oracle, 3389 RDP, SMTP email for 25, 587 for encrypted email, 22 for SSH. At least you need to know these port numbers. These are fall under the registered and well-known port number, right? So you just have a look and understand. For example, you may expect a question, what is the port used for RDP, which is 3389? What is the port used for Microsoft SQL database 1433? You must able to pick or eliminate in the multiple choice questions. So now come to securing Wi-Fi network. Disable SSID broadcasting. What does that mean? To secure the Wi-Fi network, you can disable SSID. If you disable SSID, no one knows when they connect Wi-Fi, your SSID is not visible. Next, we can go with the change default password. By default, Wi-Fi modem comes with admin at 123 or password at 123 as a password. That needs to be changed. Then pre-shared keys can be used. Pre-shared key is nothing. We are setting a password in Wi-Fi configuration and sharing with all the family members in the house, right? Hey, this is the Wi-Fi password. Actually, that is not password. That is called pre-shared keys, because you are inputting the keys in the Wi-Fi modem while setting up. That same password used to connect to the Wi-Fi modem. So that is called pre-shared keys. Enterprise authentication applicable for companies and enterprise. They connect Wi-Fi router with the authentication server. Whenever they connect the user ID and password to be entered, then only Wi-Fi will connect. That is for enterprise. Captive portal, you might have seen in hotels or airport. When they connect Wi-Fi, it asks your details like boarding pass number or hotel room number, or the specific key they given in the hotel reception. So those things will ask you a form. Once you fill the form, then will give you internet, right? That is called captive portals. So captive portal is much popular while purchasing internet for 3 hours or 1 hour through specific portal. You may need to enter credit card information to subscribe those internet services. In situation like cruise ship or airport, you can see captive portal in Wi-Fi network. Wireless encryption. This is another important concept, and you may expect definitely at least one question from wireless encryption. Wired equivalent privacy is the standard used in Wi-Fi maybe way back in 1998. WP is no longer secure. Okay, if they ask you a question, I'm using WEP to set up Wi-Fi, is that secure? No, it is not secure. Wired equivalent privacy is the full form. WEP is no longer secure. Then they developed Wi-Fi protected access standard, which is called temporal key integrity protocol. That is also no longer secure. Then they released Wi-Fi protected access v2, released in 2004. WPA2 uses encryption, still considered secure and widely used. So if they give you 4 options to pick which one is secure standard in Wi-Fi, you need to pick WPA2 and WPA3 is more secure. WEP and WPA version 1 is no longer secure. So this is just a standard. While setting up your Wi-Fi modem or mobile hotspot, the mobile give you option in the drop down which standard you use to set the Wi-Fi. So remember, if you use first two, WEP and WPA, your Wi-Fi can be hacked. That's what it means, because it's no longer secure. We need to use WPA version 2 or version 3 to secure your Wi-Fi. I just put this in this table to make it clear. Open network is insecure. You shouldn't broadcast your Wi-Fi without any passphrase or any standard, which is insecure. WEP is, I told already, that is developed in 1998, around that period. That is no longer secure. WPA version 1, which is just WPA, is insecure. Only WPA2 and WPA3 is currently used in all the Wi-Fi modem and router. But still in the drop down you will see WEP and WPA. That shouldn't be used in the secure environment or house. So if someone tried to run a the password stealer kind of application to identify the password, they could easily identify if any of the modem configured with WEP or WPA. So maybe if you are a techie guy, you go to your Wi-Fi modem and connect to your Wi-Fi modem IP address and see what is the standard configured in your Wi-Fi router. It's not that difficult. You can just go to YouTube and watch whatever modem you have, put that model number and see how to get into the Wi-Fi configuration. You will see that standard, what standard being used in the Wi-Fi. Like, yeah, it's now quiz time. Yeah, so apply the logic what I have explained to identify valid IP address and respond which one could be the right answer. All right, so to eliminate the first one, 10 274 is above 555 range, so A is not answer. B is, as I said, 127 is a loop back, like standing in front of mirror and talking to yourself, so not a valid IP. C, 194, 243, 129, 144, not matching any of the, the limitation or invalid. So C could be the answer. D, the first octet is 240, so that is not matching the criteria, right? So D you can eliminate. So the right answer is C. All right, so let's quickly move on as we already reaching the time. So now is the second quiz. Siva is configuring a Wi-Fi network for a user who will be working from home. He would like to configure the network so that it is strongly protected from eavesdropping as possible. Which encryption standard should Siva use? All right, so as we know, WEP is no longer secure. WPA2, WPA3, WPA4 no longer exist. So WPA2 also no longer secure compared to WPA3. That is the most recent and secure one. So the option 3 is the right answer. So this is how you need to apply the knowledge, whatever you have learned in this concept. Then you can identify the answer easily. So if you slightly confused, let's say WPA4 I never ever learned, but it's in the option. This is just to confuse you to identify, whether you are eliminating that or not. Really, WPA4 not exist in that list or in the textbook, so you can take care of that. If you see some option which is you never ever seen in the training or a lesson, you just put a thought that that may be just a confusing option to trick you to choose that option because which you not aware of. All right, so network threats and attacks. As I could see today, we are bit running a bit late, so I may extend the session 30 minutes today. Hope if you are okay. Otherwise, we'll record the session and post it in the portal. So now talk about network threats and attacks. So far just I warmed up you guys about connecting to devices, using IP address, connecting Wi-Fi, using protocol, YSI layer, right? So now, okay, these all good. These all helping us to connect one device to another device in this computer world. But what are the threats? So in cyber security perspective, if you know the enemies, you are well prepared to protect your assets. So you should know the threats. What are the threats for Wi-Fi? What are the threats for my laptop? What are the threats available for Bluetooth or NFC? So you are prepared to protect those assets so that cannot be hacked, that cannot be compromised, right? So let's start with some of the popular attacks like DDoS, virus, worm, Trojan as a malicious code. Then we'll talk about man in the middle attack, side channel attacks. Let's start with malware software. What is malware software? Is one of the most significant threat to computer security. Malware objects infect computer system and then perform some type of evil action. So we clearly see that the software prepared to do some nasty stuff on the computer to interrupt availability or confidentiality or integrity, right? So to interrupt something, so they develop some code or a software that is called malicious code or malware. Under malware, we have multiple types. But exam standpoint, you no need all the types. Only 3 is needed. You must know about virus, worms, and Trojan horse. What is virus? Viruses spreads from system to system based on user action. So user need to do some action, then only virus will perform. Virus will spread. What action? It could be connecting a USB device or clicking a link or opening a file or executing some command. Some user input needed to virus to spread. Okay, virus will not spread itself. The reason I'm explaining this, there may be a question: which malware need user input to spread? So you should know virus is the answer. Now come to worms. Worms spread from system to system without user interaction. They spread under their own power. So the worms doesn't require any user input. You have downloaded some file last night, you slept. Morning, your computer not turning on. You haven't done anything. You just downloaded some file or movie. You logged out last night, but the moment you open in morning, your computer not booting. Now that indication of worms, because worms, once it reaches your laptop, you no need to open the file, you no need to plug the USB, or you no need to execute the file. That does the job itself. So worms may exploit the vulnerabilities because they need some vulnerability to exploit. It cannot be violated normal process. For example, you just download a file. How come that file will infect your device and not booting up next morning, right? So it may use some of the known vulnerabilities or weakness in the system, then it spread across the network or a system, it create that damage. So worms spread from system to system without user interaction, no user input needed for worms. Trojan horse looks like a legit software, but it does some bad stuff without you knowing. For an example, there are people addicted to Korean dramas. Now these Korean dramas are given free of cost by installing some application. Let's say, for example, XYZ application. If you install that application, you can watch Korean drama. Now what people are doing, they think, hey, some application is giving Korean drama free of cost. That is legit purpose what human is thinking. They go and download the application on the mobile, they start watching the Korean drama. But that application, that XYZ application, collect the user's gallery, photos, contacts, send back to the victim, the attacker, and the attacker is gathering the data. This is just one example. Similarly, let's say you go and search for some PDF converter application. You are in a hurry to convert some scanned document into PDF. You don't have default capability in mobile. You go to Google and search PDF converter software for mobile. You are getting the first link and installing that software. Now that software posts like a legit PDF converter, but with that converter, it has some additional payload to download some other software and that steal your data or information or capture your net banking information that can be used to transfer your money without you knowing, or even it can forward the SMS, the OTP, whatever coming to your mobile phone to the attacker. That's how the data breach or cyber scams are happening. So Trojan horse is much danger among these two Trojan horses. Definitely, it's so harmful. That's why the mitigation is here. We need to stop installing unknown application on the mobile devices. In companies, how they do, they manage inventory management or centrally administered systems. So as a user, you cannot install any software what you want in the company laptop. They put a control. You can't have enough privilege to install. But when it comes to personal device, we don't care much, right? So then generally we download and install any software, but that secretly doing some nasty stuff on our mobile devices. So if you are installing any unknown application on your Android or iOS mobile, go and check what that application is really doing. It may already stolen your data or silently stealing for years. So that's how Trojan horse works. So Trojan horse definition is they pretend to be legitimate piece of software that a user might want to download and install. So they pretend like Korean drama application to watch the drama, but it does the bad thing, it download and steal the information, right? Similarly, that PDF converter, it does the PDF converting job, but along with that, it does some bad stuff without user aware of. So that's called a Trojan horse. So Trojan horse, user input is needed. Human needs to be tricked and get installed that application. So there is a user interaction is needed. Virus, we need user interaction. Worms, you need user interaction. Trojan horse, we need user interaction. Trojan horse, the additional information is it poses like a legitimate software, but it hides some bad stuff in it. Next, eavesdropping attacks on path. On path attacks are nowadays very less, but still for learning purpose, we should know what is on path attacks. When you send anything on plain text, which is HTTP protocol, HTTP, not that yes, HTTP, just plain text protocol, anyone can see the message what you are sending. So using encryption is the only way to mitigate on path attacks. Man in the middle attacks and DNS or poisoning, as I said, if attacker go to DNS and modify DNS entry, google.com with attacker server IP, facebook.com with attacker server IP, attacker hosts similar pages, Google and Gmail or Facebook login page, and trick user to enter the user ID and password and steal those information. Similarly, net banking, they develop same like banking application. They go to DNS server and change the IP address. Now user go to that banking app and they get scammed because they thought it's a legit banking application, but really that attacker poisoned the DNS and routed the user towards fake application, and that harvested the credential. In public, DNS more secure, but in an environment like you are connecting public Wi-Fi, the free Wi-Fi available anywhere, you don't care about security, then you may get scammed easily. For example, in cities like London, you may find some free Wi-Fi's on the street. The moment you connect, it may redirect you to google.com. You think that is a legit Gmail application. You enter your Gmail ID and password in a hurry to connect. But actually that Gmail could be dummy fake application. They are harvesting your credential in the backend. So those type of attacks can happen using DNS or poisoning. That's the reason recommendation is to do not connect free Wi-Fi. Whenever you travel, you try to connect authorized places like airport or wherever you have seen trusted places. Do not connect random cafe or random places, random Wi-Fi if it is available. Then denial of service attack, primarily disrupting the legitimate use of a system. Like denial of service attacks as an example, I think every festival season, Amazon, Flipkart put the deal, right? the big day sale kind of a deal, they expect more volume of traffic to their web pages. So that time what will happen, the attacker will initiate attack towards their website and try to make it down the application so that the users cannot order anything, their business will impact it. So the motive here is, could be competitor paying the attacker to do that, or maybe the legitimate reason. It could be attacking by nation, or one country to another country. They do they do attack the specific country. So that used denial of service attack to disrupt the availability in the CAA triad. We have seen in the network security principle confidentiality, integrity, and availability, right? So where availability can be disrupted using denial of service attack, but the fix would be company should implement firewall and they block the attacker IP address so that DDoS can be mitigated. That is where another technique called distributed denial of service attack come into picture. DDoS attack come from the DOS, denial of service attack come from one source, so easily you can block the IP to fix that problem. But distributed denial of service attacks, let's say hundreds of attackers connect together, attack comes from 100 IP address to one web server, then that we cannot easily block that IP address, right? So that is where distributed denial of service we may not able to fix using firewall. We may need ISP or a specific solution help like Cloudflare or Akamai. They help to mitigate distributed denial of service attacks. So when you are a security officer or a security guy who implementing solution to your company, you may need to buy any one of the solution from Cloudflare or Akamai to protect this kind of network disruptions to safeguard your servers. Now side channel attacks. Side channel attack is something like understanding the behavior of your processor, the electromagnetic field in the data center, then they decode the computation process. Take as an example, let's say your computer takes 57 seconds to complete the specific task. That 57 seconds, maybe the electromagnetic field around the server is measured by some external device. Using that information, they would identify and mimic the attack or take the data out in the encryption process. Let's say your computer is trying to encrypt something that emits some electromagnetic field outside, placing a device nearby and capture those signals and try to decode the data. That is how side channel attack works. Primarily side channel attacks, you need physical access to that primary system. If intruder or attacker reached your data center and try to steal some heavy sensitive information from the server, then they use additional devices to capture the electromagnetic field and power consumption, timing calculation along. These all work together to decode the data. So the side channel attacks you just need to aware of. That is also one of the threat we have. So now is the quiz time. Samraj is the system administrator for small business network that is experiencing security problems. He is in the office one evening working on the problem and nobody else is there. As he is watching, he can see that system on the other side of the office that were previously behaving normally are now exhibiting signs of infection one after other. Which type of malware is Samraj likely dealing with? So, which we explained, virus, worm, Trojan horse. So, what would you think? Which one Samraj is seeing? So, here some hints are available in the question. So, try to decode and identify. Guys, come to chat and put your answer, right or wrong, no problem. Just try. All right, so Samraj is the system administrator for small business experiencing security problem. He's in the office one evening working on the problem. Nobody else is there. He's watching. He's just seeing one system, other like system on the other side, previously behaving normally, now exhibiting signs of infection one after other. Like let's say in office, 15 systems are there. Suddenly one after other behaving abnormally. No user. The hint is nobody in the office, nobody else is there. So there is no user input. Systems are just connected and maybe the wallpaper seen. Now he's just noticed, abnormal behavior. One after other is getting, infected. So this is clear sign of no input, no user input. Among virus, worm, Trojan horse, which one doesn't require any input is worm. So worm is the right answer. Virus and Trojan horse is not a right answer because virus need user input, Trojan horse need user input. So that's how you need to figure out the right one. So logic bomb, we haven't spoken, but that's not in the scope. So that's just confusing you to, figure out. But worm is the right answer because no user input is needed here. So next one, which one of the following statement about denial of service attack is incorrect? All right. So we have seen two type of network attack, DOS and DDoS, right? DOS is denial of service. DDoS is distributed denial of service. DOS comes from one attacker. One attacker send large amount of packets to the application. Now, the question is asking us to figure out what is incorrect in the given statement. So they originate from many different sources. Yeah, that is obviously incorrect because DOS is always comes from one single attacker. DDoS is come from many different sources. I mean multiple attackers. So first one could be the answer. Let's cover other answer as well. They can disrupt the availability of system. Yes, obviously DOS is disrupting the availability, but this is a correct answer, not the incorrect about the attack. They require large amount of bandwidth. Yes, this is also DOS behavior, which is correct, but question is trying to figure out the incorrect one. The fourth one is they are easily detectable. Yes, DOS is easily detectable as this comes from single IP address. They can block using firewall. So the right answer is first one. They originate from many different sources because they are trying here. The question is tricky. They are trying to figure out what is incorrect in the given form. So the 2, 3, 4 are correct. Only the first one is incorrect. So threat identification and prevention. Now come to primarily we have seen some of the disruption, right? Like threats for network security. Now come to prevention side. Let's say you have virus, worm, Trojan. How to fix that problem? There is a way, right? So using antivirus has two processes. One is called signature detection. Another one is behavior detection. Signature detection, across the globe, whatever malware already created, they take that signatures. What is signature? Probably MD5 hash. They keep it in the database, and while scanning, they validate all the files against that known file. signature and identify if there is a file exists. They give the result, hey, there is a virus in your system, let's quarantine or delete the file. Antivirus do using signature. In layman term, if I say, let's say I have 10 keys. I use that key to identify if that key exists in the system. If that key matches, then identify there is a virus, because that 10 keys are already known key that is being validated against the available key to match. Now come to behavior. Behavior is something like 0-day virus. Let's say virus developed 30 minutes ago. None of the antivirus has visibility. Now I installed that virus in the system, or I'm spreading to all the users. That virus designed to do some bad stuff. Antivirus will monitor the system process and behavior and identify if that behavior is matching the pattern of the virus, then it identify that as a malware. Always antivirus not only looking for only virus, it can detect worm, trojan, logic bombs. So whatever malware exists in the world, antivirus can detect it. But we kept the name antivirus for that software, but that doesn't mean antivirus only detect viruses. Antivirus can detect even behavioral detection as well. So if you developed any Word document which does some logic in it, it behaves abnormally, then your virus software detect that as a malicious code and clean that file as well. So antivirus can detect based on behavior, based on signature. Now come to intrusion detection and intrusion prevention, which is called IDS and IPS. Intrusion detection system, intrusion prevention system. Intrusion detection system is continue to monitor the traffic and identify if there is a pattern for virus. Take WannaCry as an example. WannaCry is a malware. It was very popular in 2015 time period. What it will do, it just use spread across the system, and it encrypt the system and ask ransom to unlock the system. That is called WannaCry ransomware. Now, if you have an intrusion detection system, it only tell you there is a ransomware. It was maybe 2015 time period. I mean the detection signature period was 2015. We have seen that pattern in the logs, intrusion detection system. It will not react anything. It will just inform you about, hey, there is a system, there is a detection of ransomware. But what intrusion prevention system does, you can write an action. If there is a pattern detected, go and isolate the computer. Go and disable the internet for that computer. Go and disable the LAN connection of the computer. Terminate that computer from the Wi-Fi. So those actions helps companies to avoid spreading the malware. So somehow malware entered the computer. Now trying to propagate or spread across other system. Now intrusion prevention system block that action by continuously scanning and applying the action. So the primary difference between intrusion detection and intrusion prevention is one is one can act, which is intrusion prevention system. One can completely only monitor and alert, which is called intrusion detection system. So this intrusion detection and prevention available in the form of endpoint as well as network. If you just install intrusion detection system on your computer, which is called host-based IDS, HIDS, which is host-based. The network-based IDS can be installed on the network. I mean, your router, your modem can be deployed with the network-based IDS, which will mirror the traffic and understand the pattern. Computer A, what is talking to computer B, computer C, or whatever system available in the network. All the system will connect each other and understand the pattern, and based on that it will apply the control. So the exam standpoint, you should know what is intrusion detection, what is intrusion prevention system, then host-based IDS and network-based IDS. So the IDS also works based on signature and anomaly detection. Signature, basically the already known malware or action, right? For example, take any known virus or worm. The worm probably it would use XYZ pattern. Let's say worm first it spread to another system, it connect to public IP. That pattern already recorded in the IDS signature. If that pattern is detected in the network traffic, then it detect that as a malware and it block the system using IPS. If they have only IDS, it will trigger an alert to the security administrator or SOC team to alert there is a computer which is get infected, antivirus failed to clean the file. These are layered security approach. If antivirus fails, they have IDS, IPS. If IDS fails, they may have other solution to mitigate. So they would use multiple solution to mitigate. But exam standpoint, antivirus, IDS, IPS. What is host based IDS? What is network based IDS? Then signature detection and anomaly detection. Next, classification of errors. What is false positive? What is false negative? False positive is, for example, your antivirus triggered an alert, there is a malware. You go and check the system, you couldn't find the malware. That is called false positive, because your antivirus detected something as a virus, but really that is not a virus. That is false positive. False negative is really there is a virus, your antivirus failed to inform you, or the system failed to alert you, then it is called false negative. So just to aware, maybe you may get tricky questions around this. What is false positive and what is false negative? So next, about firewall. Firewall basically used to mitigate security attacks, right? Like a DDoS attacks. When denial of service attack happens, you can write a rule about attacker public IP and block. So you are applying a policy, that policy being applied in the firewall so that the attacker traffic never pass the firewall, your web server or database server protected from DOS attack. So primarily request should be allowed or denied according to the organization security policy where firewall is used. Firewall might have three interface. One is called demilitarized zone, which accept the internet bound traffic from the internet. There is another interface called internal network, which connects to your internal private application or private computers, printers, all fall under internal network. There is one interface connected to internet, which is called WAN, wide area network. So this is just a basic firewall, but if you go in depth architecture, there would be multiple firewall in each section for more security. But for this exam specific, you must know what is demilitarized zone. Demilitarized zone is where your web server or email server located that will accept traffic from internet. That is called demilitarized zone. If there is an attacker attacking anything, the firewall, we can write a rule to block that attacker IP address. That is where we put firewall before demilitarized zone. So now time to evaluate your capability here. Jaya recently analyzed the results of a vulnerability scan report and found that a vulnerability reported by the scanner didn't exist because system was actually patched as specified. Which type of error occurred? So more precisely, there is an error, but actually that is not exist in the system. We have seen just 2 slides before the error. Yeah, all right. So the false positive is the right answer because the error triggered Yeah, the error triggered, but really that error not exist in the system. So that is false positive. So next we'll quickly cover network security infra protection. So data center, we need to take care of air temperature, humidity and fire safety. So air temperature, we need to maintain 64.4 to 80.6 degree Fahrenheit. Humidity, we need to maintain 40.9 and 50.0 degrees Fahrenheit as a humidity. Fire, we cannot use wet pipe, which is called the red color pipe filled with water, right? That cannot be used in data center because all our electronic equipments, if there is a leakage, there is a risk of water may contaminate electronic devices. So for fire, we need to use specific chemical based equipment or empty pipe. They just put an empty pipe without water. If there is a fire incident, they fill the water on demand. So that's how fire safety for data center given. These all are given to, the air temperature. If the temperature is so high, your electronic devices may lose the life. So that's where electronic devices to be maintained with specific temperature. If you have seen any data center, you might see, it's the data center always very cold than the outside temperature. So 60.4 and 8.6 degree Fahrenheit is the recommendation by international standard, and humidity between 40.9 to 50 degrees. If humidity increases or decreases, there would be a chance of the electro connectivity may happen, or static electricity may formed, and that will impact the servers and routers or whatever devices placed in the data center. Why we need to learn about these air, humidity and fire? Because these are threats to your computer equipments that fall under cybersecurity. So we should aware of these external threats as well. Now quickly come to cloud computing. Cloud computing, we have horizontal scaling and vertical scaling. Before go to scaling, what is cloud computing? Behalf of you, someone else is giving you computation power on demand or pay per use. For example, Amazon or AWS or Google Cloud or O365, you go and pay something for your service, you go and deploy servers or applications, right? So cloud computing, behalf of you, someone else is producing computing power, on demand or pay per use. So multiple level of service they are offering. That is called cloud computing. Now horizontal scaling, let's say you have a web server that only can support 1,000 users per minute. Now you have a huge demand on your product. Suddenly 4,000 users coming. You need to scale the server into 4 different servers from single server. Now you can just add 3 more servers in the cloud. That is called horizontal scaling. Vertical scaling, instead of increasing the additional 3 servers, the first server itself, you are scaling the RAM, CPU or hard disk to maybe 124 GB or whatever TB you need. That is called vertical scaling. So horizontal scaling, you are adding the servers, more servers to support the computation power. Vertical scaling, you are just increasing the resources within the existing server. So horizontal, vertical scaling you should aware of. Then cloud deployment model, we have private cloud, public cloud, hybrid cloud, community cloud. Private cloud dedicated to you. You pay to someone, that someone will provide you dedicated resources. Could be web server, load balancer, database server, only to you. But what you would pay, you would pay entire services as a contract. Let's say 3-year contract, X amount, maybe 10 crore you are paying for 3-year contract. That is called private cloud. No other customer will have access to that private cloud. That is dedicated to you. So this is primarily used in highly secure environment, as well as the governance places where the system cannot be shared with someone else. So private cloud is much higher cost, but it will give higher security because you are the only guy going to use that private cloud component. Now come to public cloud. AWS, Google Cloud or whatever services from Azure, we have multiple people using the same component, right? Let's say EC2, you go and spin a EC2 in AWS or Azure Cloud, you are spinning a VM. Then the same hardware used by n number of customers. So we don't know Microsoft customers, how many people connecting to the same server. So the resources shared across multiple people, the data disk may be shared with multiple people. That is called public cloud. Again, the paying model is pay per use or based on contract. You can pay. Hybrid cloud is mixed of both private and public cloud. Certain component in private cloud or your in-house data center, certain component in public cloud. That is called a hybrid cloud. Community cloud is similar, entities, they do some common project. For example, 10 universities connect together and buy some cloud space to connect multiple students from different universities for a collaboration. Then they use community cloud, because community cloud not owned by any one university, maybe 10 university pay for the same cloud and the resources shared across 10 universities. This is just one example. Similarly, let's say 10 companies group together and form some new product or a project. They pay for that service, and 10 companies share the same resources. That is called community cloud. Now come to the different offering by the cloud, right? This is just example just to make you understand what is infrastructure as a service, what is platform as a service, what is software as a service. The first one you can eliminate because that is called a traditional on-premise service, which is exist in the traditional way, right? You host everything on your data center like server, load balancer, router, switch, whatever equipment you need to host the service, you host everything in your data center. That is for traditional one. But exam standpoint, you need to know what is infrastructure as a service, what is platform as a service, what is software as a service. First one, software as a service, is very easy. Everything is managed by the service provider. For example, you go and buy 10 TB email service from Gmail. Your Gmail account completely managed by Google. That is called SaaS. You go to Salesforce and buy Salesforce instance. Entire Salesforce server, code, application, patching, everything managed by Salesforce. That is called SaaS. Everything, you just go and pay, get the service. But for platform as a service, you can, you need to do, your own development or own component, but they give base with till operating system. On top, you need to deploy the, application. But for infrastructure as a service, they give very base operating system or hardware level capability. You need to install the OS, then on top, you need to, add the application. So more precise, this one is, this slide would explain more. SaaS, everything is managed by service provider. For platform as a service, you can see runtime, middleware, operating system owned by the service provider. You just install the software and data for PaaS. Infrastructure as a service, they only give VM. You need to install the OS, application, middleware, data, application or runtime. That is managed by you. So this is the difference. So exam standpoint, you need to know that last 3 column clearly. You need to differentiate what is SaaS, what is PaaS, what is IaaS clearly. So this is one of the important section. You may expect questions from here. So now come to security and shared responsibility model. For example, again, we need to refer this slide. For example, first talk about IaaS, right? IaaS, we have responsibility on operating system onwards. Operating system onwards, the company responsibility. The base hardware, server or rack or data center, that is taken care by service provider. Now, the shared responsible model, hardware and data center managed by the service provider. As a customer or you need to configure operating system, application, data, securing those elements in primarily customer responsibility. In platform as a service approach, customer still responsible for the data and application, but doesn't directly interact with the operating system. In platform as a service, operating system taken care by service provider. In SaaS, everything is taken care by service provider. You just as a user and know how to use the data and application. So with that, I conclude this session. If you have any follow-up questions, post it on the chat. We'll take for quick 5 minutes, then we'll wrap. All right, everyone. If no further questions, we'll wind up. Thank you very much for joining today on this weekend. Hope this session is informative. Probably the next session would be the last one. Meanwhile, I will try to provide you all the mind map and whatever resources we have used so far in the session. We'll try to send an email tomorrow so that you guys get the necessary resources. I would request everyone to complete the ISC Squad training, then use my additional training as a supportive training. Then make sure you understand the concepts clearly so that you can decode the questions and apply the knowledge. Here, practical skill is important. You learn theory, then you need to know how to apply that practical while evaluating multiple choice questions. So with that, we'll say thank you and conclude here. Thank you. Bye-bye.